Hey y'all, it's me, Miss B. Today we're talking about how to simplify radicals and divide radicals. So what we're going to do is start with these warm-up problems. Okay, so these are throwback to 6.1 notes if you need a reminder. All right, so what we do is we subtract the numerator from the denominator. So we've got 2, and then n to the 2 minus 1 gives me 2n. So that right there is it for that one. Guess I can do that. All right, and then let's go ahead and do this one. So we're going to do 14 over 6. If we do 14 over 6 and simplify it by dividing the top by 2 and the bottom by 2, I get 7 over 3. So I'm going to go ahead and start a fraction where I have 7 over 3. And then I have 4 and 5. So 5 minus 4 is... so I get x to the 4 minus 5 and y to the 7 minus 4. So I get x to the negative 1 and y to the 3. To make this positive, we got to move it down, and this stays where it is. So we get x in the top and y to the third in the bottom. So that's our answer there. Oh wait, you know what? I did that backwards. The x is the one that goes to the bottom, and the y is the one that stays in the top. So that right there is our final answer. Okay, so basically this says that if we have a square, some kind of root, and they have the same index, and b is not equal to 0, so it can't be equal to 0 because we have 0 in the denominator, then we can divide if they have the same index. And we really divide radicals similarly to the way that we would divide exponents. So all we have to do is make sure that they have the same index, like was noted in the definition there. Okay, so here's some examples. All right, so what we're going to do is we're going to take each of these and we're going to set this up as a square root of 18x to the 5th over 2x to the 3rd, just like that. Okay, so then we simplify. 18 divided by 2 is 9. And we're just doing the math inside of here. And then x to the 5th minus 3. 5 minus 3 gives me x to the 2. And it is greater in the denominator. And we're left with 1 in the denominator. So then we'll just leave it as the square root of 9x squared. Taking the square root of 9, we get 3, and the square root of x squared is just x. So that right there is our answer. All right, take a look at this second one here. So we've got the cube root. So we have the cube root of 162y to the 5th over 3y squared. Just combining those because we have the same index. 162 divided by 3 is 54. And then we have, so this was 54. And then we have y to the 5 minus 2 gives me y to the 3. And so there's nothing left in the denominator. I'm looking for a perfect cube that divides 54. I'm going to list them over here. So we got 1 to the 3rd equals 1. 2 to the 3rd equals 8. 3 to the 3rd equals 27. 4 to the 3rd equals 64. And we're getting too big. So 27 is 50 times 2 is 54. So this is going to be the cube root of 27 times 2, y to the third. Okay. So then taking the cube root of each of these, they'll move to the outside because cube root of 27 is 3. Cube root of y to the third is just y, and then we're left with the cube root of 2 inside of there, not neglecting our index. So that right there is our final answer. Okay. And we'll leave those next two. Let's do this last problem right here. So I'm going to rewrite this as the cube root of 56x to the 5th y to the 5th over 7xy. 56 divided by 7 is 8. 5 minus 1 is 4. And 5 minus 1 is 4. So then the square root of 8, I have to think of a perfect square that divides 8. It's going to be 4 times 2. And then I divide each of these by 2 as well because my index is 2. So I get 2x squared y squared radical 2 as my answer. All right, we'll leave it at that. That's all for today, folks.